We're going to find the location and the value of the absolute extreme values of this given function on this interval. So maybe we should just think for a minute about what we might expect from this problem. We know what a sine function looks like. We know that a sine function oscillates. Its maximum value is 1, its minimum value is -1, and a sine of 3x just oscillates at triple the speed. Well, I didn't get it exactly right, but for every 1 cycle of sine of x, we should see 3 cycles of sine of 3x. So we should still expect the maximum and minimum values of this function to be 1 and -1. The question is, where do they occur? To find those maximum and minimum values, we need to find critical points. That means take a first derivative of our function first. The derivative of a sine function is cosine, but then the chain rule says we need to multiply this result by the derivative of the inside function. The derivative of 3x is 3, so we're just going to multiply this by a 3. To find the critical points of this function, we need to set the derivative equal to 0. We can get rid of this 3 out in front just by dividing both sides of the equation by 3. Ultimately, we need to solve the equation 0 equals cosine of 3x. What x values make cosine of 3x equal to 0? Well, the cosine function equals 0 when its argument equals pi over 2 or negative pi over 2. But since the cosine function is periodic, those aren't the only values that make cosine equal to 0. For example, 3 pi over 2, negative 3 pi over 2, 5 pi over 2. Plug any of those values into a cosine function, and that cosine becomes 0. So for our problem, our cosine of 3x is going to be 0 when 3x equals any of these values over here to the right. And we could keep going with that list forever. But we're trying to find the x value that solves this equation, so we need to get x by itself. That means that we can divide both sides of this equation by 3. And we get a really long list of all of the x values that solve this equation, which means we have a big list of all of the x values where we have critical points of sine of 3x. But we really only want the critical points on this interval from negative pi over 4 to pi over 3. So which of these answers is on that interval between negative pi over 4 and pi over 3? Well, I gave you this long list of answers, and I hope that it helps you understand this problem, but the only 2 on this interval are the first 2. So our critical points occur at x equals pi over 6 and x equals negative pi over 6. And we expect that our maximum value is going to be 1 and our minimum value is going to be -1 from the graph that we drew earlier. But let's just confirm this result. Let's find the y value of our original function at x equals pi over 6. Plugging x equals pi over 6 into the original function gives us this, which reduces to sine of pi over 2, which does give us a maximum value of 1 for this function. And let's do the same thing for x equals negative pi over 6. We end up getting, after simplification, sine of negative pi over 2, and sine of negative pi over 2 is -1. So to summarize, we get a maximum value of 1 at x equals pi over 6, and we get a minimum value of -1 at x equals negative pi over 6. And those are the 2 absolute extreme values on the given interval for this problem. I hope that it helps, and I will see you in the next video.